So it's connecting. Do you want to say anything, or you want to just get started on your own?
Let's get
Hello,
started.
I'll just say something. Hello, everybody. This is our first session of today, and I'll just hand the stage to our very talented speaker.
Okay, thanks a lot, Tio, for your kind words, and I'm really happy to be here in the low-hanging skills for software developers with amazing speakers. And we're gonna be starting with the Java challenges. And as we have 20 minutes, let's go straight to the challenges. I'm gonna share my screen. Just a moment. And you tell me if you can see my screen. Can you see my screen, guys? Can you say yes, no?
Yes, yes, we can see your screen. Yes, works fine.
Okay, perfect. Okay, so we won't have time to go through all the challenges, but I'm gonna give you a summary of what challenge we're gonna be talking about. So we're gonna be talking about deck of JDK6, and as you can see, we're gonna be talking about many Java versions, and let's get to the code right away. Okay, so there's a little story. Okay, so this is the first challenge. It's about decking, and basically what we are doing here, we are instantiating deck with linked list, and then we are using a couple of methods from the deck interface, and then we are removing and showing some of the elements of the linked list, and I will give you some time to think about this challenge, and in the meantime I'm going to show you the alternatives, okay? And if you can, please send the answer on the chat so that we can interact, okay? Okay, can I have an answer for you guys? Can you answer some of the, okay, C? Okay. Who else is trying to answer to this challenge? Okay, let's see then. What is the answer? Come on, Duke. Okay, so it's D. So why it's D? So you can see the little animation that is showing what is happening when we use the add first and the push and the add last method. The add first, as the name is saying, it's gonna add first worth, and then push will add although on the top of worth, and then we invoke the add last method, which will put Scott at the last position, and then on the bottom we are removing the first element, and we are also showing that another important thing is that the remove method throws an exception if the linked list is null, okay? And the pick method doesn't remove the element, just shows it. So that's why we're gonna show warf, and then we're gonna invoke pop that gets the element on the top of the stack and also removes it. Then we're gonna show warf again, and finally we're gonna invoke the poll method that will show the last element, okay? So linked list is useful to add elements into the top of the stack or in the last positions. Okay, let's go to the next one. Have to go really quick here, guys. So this is the ship door challenge. And as you can see, it's the auto-closable, it's the try with resources feature from Java. And we are invoking the close method from the auto-closable interface. And as you can see, we are doing some operations in the main method in the try with resources block. Okay, so I'm gonna open the alternatives for you so that you can think about the answer, okay? And guys, try to guess what is the answer. Okay, I'll check on the chat if there is any answer. D. Okay, just now, D. Awesome. Okay, so let's see the answer. Ta-da-da-da. Oh, it's C. Okay, let's see why. So the first invocation is inside the try block. So as you can see, we have the number 1, and then we're going to invoke the open method above. And then on the step 2, we are throwing runtime exception, okay? But when we throw this exception, we're going to be invoking the close method, because that's exactly what try with resources, the problem that try with resources solve. So basically, we can avoid boilerplate code by closing resources in the finally, like we were doing that before. But now with the try with resources, we actually the close method will close the resource for us. So we're gonna have those steps. So the first thing that will be printed is ship door is closed, and then we're gonna print fail to open door. That is from the runtime exception. Okay, and yeah, as you can see, the fail to open door is gonna be caught on the catch, and then in the end, the finally block will be invoked. So it's the next one. Okay, so this is a challenge about streams. So as you can see here, we are instantiating a list with those 3 elements, and then we are invoking a couple of stream methods. So let's see the alternatives then. And please, guys, if you know the answer or if you want to guess it, put it in the chat. Are you ready? Let me see on the chat. Okay, I see A, C, B. Okay, B, B, B. Okay, that's nice. Let's see the answer then. Ta-da-da-da. It's A. Whoa. Some of you got it right, which is awesome. So I'm gonna explain why it's A. So the first thing that's very important with streams is that we have intermediate operation methods, which means that they are not invoked until the terminal operation method is invoked. An example of terminal operation method is for each or collect, and there are also others. But what happens is that when there are no terminal operation methods, nothing on the string will be invoked. So it's a very important point from streams. For example, streams are lazy. What does that mean? It means that the intermediate operation methods will be only invoked when the terminal operation method is invoked. So which means that streams will be more performant because we don't need to go through all the elements. Instead, all the pipeline, all the intermediate operation methods are read, and then once we trigger them with the terminal operation method, only then we're gonna be listing all the elements. So that's why we go through the elements only twice. We don't go through them 3 times. That's because streams are optimized, and as we are using limit 2, there's no necessity to go through all of the 3 elements. So those are very important core concepts from streams, and if you understand them, it's going to be easier to master streams completely from Java 8. Okay, so as you can see, the pick method is invoked first, and then inside the for each, we are using method references, which is basically just printing each element from the crew. So method reference is only a syntax trick, syntax sugar. So that's it for this challenge. Let's go to the next one. Okay, so this challenge is about lambdas. So as you can see, we have a list, and then we are iterating over this list. Then we are doing some operations here, okay? So let's see the alternatives. I'm gonna give you some time to think about it. Okay, are you ready? I'm gonna check on the chat. Write your answer. Okay, A, C, A again, A. Whoa, everyone is putting A. Let's see what is the correct answer. Ta-da-da-da. Come on, Duke. Oh, there will be a compilation error at line 5. So this happens because we can only use variables that are outside from the lambda that are final or effectively final. So what does that mean? It means that if we weren't changing the door number variable inside the lambda, it would work correctly. The code would compile. So effectively, final variables are variables that we created but didn't change it. So any effectively final variable could be used inside the lambda operation, and if we had created our variable with the final keyword, we would be able to use this variable correctly inside the lambda as well. Okay, so we just have to be careful when we need to use a variable that is outside of the lambda, because we might have compilation errors. Okay, so I don't know if you have time for this last challenge. Well, we might have around 5 minutes. So
Let's do the last challenge.
okay, thanks, y'all. Okay, so this is a little bit more complex. I'll try to go quickly on this one. So basically, on the left-hand side, we have the structure of the project. So we have the module of RISA and the module of Vulkan. One module is requiring the other, and the other module is exporting a package, as you can see here. Remember of this slide because it will be necessary to answer the following challenge, okay? So let's see the challenge. So I'm gonna summarize what is happening on this challenge. We are using the class executor from the module RISA, and we are invoking a public method from Spock, localized in the Vulkan module, and we're also invoking a private method from the Spock class. So that's basically what is happening here. So let's see the alternatives. Okay, let's see if someone answered this challenge. D, 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 D everywhere. Okay. Come on, Duke. Oh, it's C. Okay, so why it's C? Okay, so it's because we're trying to break encapsulation, and that's one of the biggest benefits of using modules, because we really have encapsulation, because we can't break a private method encapsulation. We can't, even if we use reflection, if we use set accessible true, it won't work. Okay, so therefore, in the do method, it works fine because it's just a public method. But then when we try to invoke our private method, we're going to have this inaccessible object exception. So this will be thrown by the JVM, okay? So this would be different if we added the opens clause here. So when we open the package here to RISA, then we can use reflection and then we can break encapsulation. So the two biggest benefits of using modules is that we can really use encapsulation, and we also can create lightweight applications, which doesn't require us to use modules from Java that are not necessary. And this is very useful for mobile applications, for example. And it also helps for enterprise applications, because then we can use less memory and we can create more effective Java applications, okay? And that's it, guys. I just have a very quick gift for you here. I have the Challenger Developer book. Let me just go fast here. So you can get this book for free. This book will help you to really improve your skills as a software engineer. I, for example, teach the technique of deliberate practice, which helps you to be really good at any programming language. Like, for example, you can be a Java specialist by using the deliberate practice technique. And you can get this book, you can learn a lot, and you can evolve in your career and get better as software engineer. So I'm giving away this book. Take advantage to get this book. And if you have some extra, I have some extra time, I will be, after the talk, I will be available. So for those who want to talk to me, I have a special deal for you. So you can talk to me. I have a very special deal that will massively help in your career, okay? So that's it then for the Java Challenge talk. I hope it was useful, and it was great to be with you guys here, okay? I'm gonna stop sharing my screen.